Okay, great. Everything is working now. I'm seeing everything's working. So let's get started, right? I'm going to begin by sharing my screen so you all have a look at the activity, right? So share your entire screen. Yeah, good deal. Right. So again, welcome everyone who has now joined in. We are about to begin. My name is Mr. Ramdat, and I will be guiding you for the next 4 days for our review session, basically our crash course. The method we are using to handle this session is I'm going to analyze how to answer these papers on a question by question basis. So we have a 4-day program. On the first day, I'm going to be looking at how to handle questions 1 to 3. The other day, we'll be doing some of the questions, and every day we'll try to squeeze in some multiple choice. And on the final day, we'll try to see if we could get some more multiple choice on the way. Okay, so that's the agenda for the next coming days. Now, as it pertains to CSEC Maths, there's a lot of fear associated with this exam, but a prepared student has nothing to be afraid of. And you all are doing the right thing. You'll have weeks still ahead for your exam, especially the paper 1, that's a little distance away. You have enough time, right, if you get serious with your studies, to make a lasting impact, right? So let's see how we could analyze some of these questions here today. So firstly, you should be aware that there's around 10 questions in your paper. That gives you an idea of how much time you could actually spend per question. Now, some you may choose to spend more, some you can spend less. But on average, you shouldn't spend more than 15, 16 minutes per question. Because of the program, what we're doing today, how I'll have to kind of explain some of these questions to you guys, we might take a little more. Right, so let's hope we could get the whole document finished today, which I prepared for you all, right? Especially for you all. So if at any moment the audio is given any difficulties, just please raise your hand or someone let me know so that I could just use a different avenue and I'll be able to rectify that issue. So that goes for the next few days, right? So everything should be working out well. So these past papers, you would see I'll upload this document for you when I have the answers on it. So I'll upload this on the course shell at the end of the session. So you will have the answers to all of these questions. But we are not just looking at the answers today. In case you're thinking, I could just Google the answers to this. That's not the job. That's not my job here today. That's not the point of the session. Knowing an answer cannot do anything for you. The journey to get that answer is what is important, because your exam questions will never be identical to what you see in here today. Indeed, your exam questions might be similar, but you may have to use a similar approach, at least a similar approach. So that is really what I want to, I hope you all pick up on. It is the method we're going to be using in tackling some of these questions. Okay, so let's get started with this first question. Now, I just want to ask, can you guys unmute and stuff? Is that, I believe that should be allowed, right? So if I ask a question, I may quicker, well, the volume of you here might be a little difficult because students might talk over each other. So you can choose to post your answers right in the shell. I may not be able to always be monitoring this, but if I say something and you want to answer something, just unmute. Most likely a lot of you will be saying the same thing anyway. It would basically amplify that. All right, so let's get started with the first question. So I know you're eagerly awaiting how we will handle a question like this. This is from 2022. I restricted all my questions. The latest is 2021. I wanted recent questions. I have two questions. I sampled 2 questions between the years of 2021 and 2023, included, well, this is including the January exam that just passed. I have picked certain questions that I choose, well, I think covers a great diversity of the syllabus from these 3 years, right? And I'm eager to start working on this. So in a question like this, what would you do? right? So using a calculator or otherwise, find the exact value of. Personally, I would use my calculator. Personally, because if you look at the amount of marks being allocated here, it's 1 mark. I would not want to spend 10 minutes doing this type of mathematics. It does not make sense. So if you have your calculator and you are versed in how to use your calculator, it could be a sharp calculator, it could be a Casio, it could be a Texas Instruments, any calculator that you all have. You could choose to use that calculator. Now, because I know some of you may not have access to your calculator right now, or actually not have access, some of you may not be proficient in doing these types of fraction work on your calculator. Let's look at how to do this question otherwise. Otherwise simply means pen and paper. So we have a question where we have 7/8 add 1/6 divided by 2/9. Do we add 7/8 plus 1/6 first? Or do we do the division first? What do you think we might have to do in a situation like this? What would you do first?
Division.
Divide.
Very good, right? So I like how the answers are not jumbling. That is excellent. So I would like to.
You would use board mass.
Very good, board mass. And indeed, that is what I am going to write here for you. All right, so BODMAS, board mass. Let's see where division is located. Division is up here. Addition is all the way down there. So we must do the division first. Are we okay with that? So you all could have your calculators ready too, so you could be checking over my work. Everyone is prone to mistakes. So let's do the division first. We have 1/6 divided by 2/9. So how do we go about doing this division? What do we do? Well, for the interest of time, and because it's such a lot of questions, what we would do here is just take the 1/6. And what do we do to the 2/9? Anyone knows?
You flip it.
Flip it.
Very good.
Do the reciprocal.
Reciprocal, very good. So it will be 9/2. So what is 1/6 times 9/2? We could reduce this a little bit, right? And we could do some stuff to this. Or we could let's just multiply it across. 1 9 is 9, 6 2s are 12. Can't 9/12 be reduced a little bit?
The 3/4.
3/4.
Right. So 1 3 3 2 3s are 6, 3 3s are 9, 4 3s are 12. So are we finished with the question?
No.
Very good. We still have something to do. Okay, we need to do the addition portion now. So now we take the 7/8 and we must add it to the what? To the 3/4. So this is the next step in our addition. Now, when we add in fractions, the most important thing is to look at the denominators. Do we have the same denominator? No. So what do you think we need to do?
Find the LCM.
LCM.
Very good. Now, I use a method here, but it might be a little. So I normally draw a line. I don't know if anybody's familiar with this method. Put the LCM below. So what is the LCM of 4 and 8? 8. Right. So we are basically finding something called equivalent fraction. So those who are not familiar with this, this is simply equivalent fractions. We want to bring both fractions. These are the two fractions here. We want them to both have the same denominator. So that is why we found the LCM. The LCM was 8. So 7/8 is still 7/8. But if we have 3/4, all right, and here for those, let me use a different color, all right? I want for those who may not like this method, let me show you something. If we have 3/4 and we want to convert this to a fraction with the denominator is 8, okay? Do you realize that 4 multiplied by 2 gives us 8? So 3 multiplied by 2 will give us 6. So the equivalent fraction for this will actually be 6/8. All we do now is add. 7 add 6 is 13, right? Oops, not right there. Very good. So this answer will be 13 over 8. You can leave it as the improper fraction, or you could convert it to a mixed number if you want. Okay? So a mixed number, what would be the mixed number of this? It would be 1 and
1
what?
and 5.
1 and 5 over 8.
Very good, right? 1 and 5 over 8. You can leave it like that. That's the first question. Right now, let's look at B. I know the question is a little bit blurry here, but I'll write it over. This one is 8 over 0.4 to the power of 3. Now, honestly, just use your calculator for this one. All right, so you all who have your calculator, take your calculators and try to see what you're going to get if you input this into your calculator. What you can do.
125.
8,000.
105.
All right, so let's just see. In case some of you don't understand the cube, let's see what you could do. So that will be 8 divided by 0.4 cube is 0.4 times 0.4 times 0.4. That's just to help students who may not be familiar with the cube now, right? And regardless. So we got some answers in there. I heard at 8,000, right? But that's not entirely correct. But I heard the correct answer predominantly. The correct answer for this is indeed 125. Okay, so those who got 125, very good. If you did not get 125, don't be alarmed. Try this question over. Use this method here and see if it could help you to get your answer. All right, so we good with this? We're moving on because of the volume of questions I want to get covered. I'm quickly going to transition to number 2. Okay, so this question as well requires you to plug in stuff on your calculator. This is a calculator type question. So we have the root of 26.8, which you could put on your calculator, take away 2.5 to the power of 3 over 2. In case you can't see the question because it's blurry, I wrote over the question here for you. So let's put that 3 over 2 on top there, so it's going to look like a power. This is something you could work in parts, or you could input it directly into your calculator. So I would like to see you all try. What do you get? What would you get? You don't need to approximate it to anything as yet. What you're getting as a raw figure for this thing. The root of 26.8, I'm working it as well, minus 2.5 to the power of 3 over 2.
1.22.
Very good. That's actually the answer to 2 decimal places. But if you plug in this whole thing into your calculator, as students, you may get something looking like 1.2240. And it have more numbers, right? 40, 2, 4, 5, 6, 7, etc. But the question wants it to 2 decimal places. So what is a decimal place? This is our decimal point. We need to look at the numbers after the decimal point. So let's count 2 numbers after the decimal point. So this is 1 number. This is 2 numbers after the decimal point. So because we are approximating to this number, we look at its neighbor. If the neighbor is more than 5, you raise the 2 to 3. But because this 4 is less than 5, we don't need to raise any numbers. Our answer approximated would just be this, 1.22. Okay, guys, this one requires you to really know your calculator. So this, for those who got this one, could raise your hands. Let me just get an idea of how much of you got this one correct. All right, here some hands being raised. Hopefully you're all trying it. All right, okay, that's not, I'm gonna scroll all the way up. Quite a lot of you here. Right, I've seen a lot of hands raised, so that means a lot of you are confused. Okay, let's look at it. D just now. How you get the power? Like how I got the power, or how the question here has the power in it. This was the power here. So the question is how to input the power into your calculator. That might be what you might be asking. Okay, so if you have a sharp calculator, just give me a second. I have a sharp calculator on hand. 1 second. Right. So for those who have a sharp calculator, now if you have a Casio calculator, actually, these questions would be so simple. Now, this calculator is not right. Let me see if I could. Right. So if you have the sharp calculator, not the one with the solar panel, I'm not sure the calculator you're using. In the scientific portion of the calculator, where we have the HYP, SIN, COS, below that, there's a button Y, X. I don't know if you could see if your calculators are sharp. I'm assuming most of you have a sharp calculator. The YX button is your power button. So if you put something like 2.5, you type 2.5 into your calculator, you press that YX button, then you could put 3/2. And the fraction button is ABC. Remember, the ABC button on the sharp calculators are your fraction button. And if just the 2.5 to the power of 3/2 should give you 3.95. That is just a little bit. This is something that you could input into your calculator. If the problem is using the calculator, then the best way to handle that is looking at videos online. And the videos online, there are a lot of YouTube videos where people have tutorials on how to use your calculators. That is very important to make sure you're going. If you don't know how to use your calculator, guys, you don't know how to find sine, inverse, all of these things, you're going to run into some issues. So if you're putting this into your sharp calculator, what I would do is use brackets. I would put a bracket here. And this would be in a bracket as well. Make sure you use brackets when necessary when you input certain things into your calculator. Okay, so these questions, which you use in your calculator, these will be a little more difficult for me to guide you with. But when we come to the algebra portion, which I know a lot of you maybe love because algebra is such a nice thing, we'll be able to I'll be able to go into step-by-step analysis of the algebra. So I really counting on you guys' ability to use your calculator for this particular question. And I did talk through how you could use it. You could get resources on your calculator. You know, if you look at the calculator, you will see the model number, right? In the back, on the top above the display panel, like EL531X, Google it, YouTube it, and make sure you're familiar with how to use your calculators. These types of questions test your ability to use your calculator. Okay. Quickly, let's just quickly look at this part of this question. This one is actually this is a good question where I can help you all look at the step-by-step analysis of this thing. We have a consumer arithmetic question here. So the question has, children go to a rodeo camp during the Easter holiday. Miss Rika, or Reka, or however you want to pronounce that, buys bananas and oranges for the children at the camp. We were given the cost of the bananas per kilogram. And they told us that Miss Rika bought 25 kilograms of bananas and received a discount of 12%. How much money does she spend on bananas? It is not a difficult question here. Some of you you could start working it by the time, but I'm going to put down the solution for this question. I would start the question by stating what I have. I know that 1 kilogram of bananas cost, how much does it cost? $3.85. That is what they told us. Okay, that is what they told us. She bought 25 kilograms. So how would we find out for 25 kilograms? 25 kilograms.
Multiply.
Very good. 25, right,
Multiply.
because we know for 1. So to find for 25, all you need to do is multiply 3.85 times 25.
You'll get $96.
That is what you...
and 25 cents.
9. Okay, right? So this would be equal to 96.25. Thank you for the working. So all we're doing is, because we know for 1, we just multiply it by 25 kilograms to get the cost of 25 kilograms. Now, that's not the end of the question. This also said she receives a discount of 12%. So this $96.25 is going to be the total price without the discount. This is how much you would have paid without the discount. So what do we do? Now that we know she gets a discount of 12%, you could find 12%, which is 12 over 100, multiplied by $96.25. This calculation is very important because this is going to give you the discount she got in dollars.
$11.55.
Very good. That is true. It will give you $11.55. This is the discount. This here was the total. How much money does she spend? So if you go to buy something, and this total is the actual cost. Let me increase the size of this. This is the actual cost here. And they tell you you're getting an $11.55 discount. What do? Would you add this discount, or would you take it away from the actual total price?
Minus it.
Very good. You must always remember to take away a discount. So that would be 96.25. Take away 11.55, and the discounted price will be, what is
$84.70.
very good, 84.70. Okay, so this one wasn't that bad. That is the answer. All right, so that one is not that bad. Let's move on to part 2 because I'm looking at the time, and we're on page. We'll get through. Somehow we'll get through with everything and not worried about it. Right? So what we have here is a question I like to consider as a trick question. Look at this question. This Rika spends $165.31 inclusive of sales tax, on 15%, or inclusive of a sales tax of 15% on oranges. So she spends this amount of money, and this amount of money she purchased oranges with it, but the money includes a tax. Calculate the original price of the orange. Now, a lot of students will be tempted to do this. 15 over 100 multiplied by 6.31 over 1 or something. Raise your hands if you would do this. Be honest. You have to be honest with yourself. If you don't want to be honest, that's okay. But if you go to do this, you're going to run into a problem. So I'm guessing no one raised their hands because I'm not hearing no sound. Normally I hear a custom hearing a sound. Oh, I'm seeing all the comments coming in over here. Oh, a lot of you raise your hands. Oh my goodness. All right, sorry, now looking at this. Right, so if you would have raised your hands, guys, unfortunately, you would be making a very huge mistake. And I will tell you why that would be wrong. If you find 15% of this number, and hear what? The best way to show you this is by getting the answer and working our way backwards, and you will see it. The problem with this question is that this number already includes the tax. By taxing this number, you are going to end up with a larger value because this number already includes a tax in it. They didn't say 50. This is if this was the origin, if this $165, yeah, was the original price, then you could tax that. You could only tax your original price, not your final price here. And let's look at how to handle it then. And then we'll tax it and we'll get back the answer and we'll work back to this number today. Let's actually just tax the let's look at how to do it. This is actually a semi-ratio related question. I know some of you, as you hear ratios, you get scared, you kind of block off mentally from that, right? It's a kind of a ratio. Watch what I mean by this. The original price, and I'm going to make a little note here, ORIGINAL, the original price. Why did I write a F? Original price. The original price is going to be 100%. That is something that we use as a guide in these types of questions. Whatever the original price is, we consider it 100%. Because this price is inclusive of a tax of 15%, what percentage do you think this $165.31 will represent?
115.
115%.
Very good, because right. So this is the final price. I'm going to write final price for now. Final, final price. So the final price is actually going to be 115%. Because why? We including the 15% tax here. And this is the key to solving this question. Now, we know what this final price is. I can erase this and write the number. We already know this value. This value is $165.31. So I'm going to write it in here. $165.31. This here is the final, this is the final price, which represents 115%. Okay, better yet, for the sake of your notes, let me leave the word final price here so that when you're looking at the notes, you'll see it. Okay, I'll just leave the word final price. Final price. All right, so with this bit of intuition, watch how easy it is to do the question now. So what I would do is, because I know 115% is basically equal to $165.31, because that's what we established. The final price is 115%, so I just wrote that back here. Right, that is what we established. What we want to do is find the original price. What percentage is the original price? 100%. So we want to find eventually 100%. But before we could work all the way down to 100%, how would we find 1%? You could skip this step for those who really like, who here may have done some chemistry and moles and stuff. Ratios would be quite easy for you. But let's find for 1% first, then find for 100%, and that would be our answer. 1%, for those who may not want to say it, would just be $165.31 divided by 115. That would be 1%. So 100%, which would be the original price, that will be whatever 1% is, multiplied by 100. So that would just be 165.31 over 115 multiplied by 100. If you were to put this into your calculator, you are going to get the original price. Right? So when we get the original price, I'm going to tax it and we're going to get back this number. So we're gonna check over our answer after. So all we did is we know the price they gave us is the taxed price of 115%. If we find for 1%, we can then multiply by 100 to get 100%. That's this calculation here. So anyone has an answer for this?
$143.75.
100.
All right. Everybody, that's the consensus, right? $143.75. So if this is the original price, let me write that in brackets here. If this is the original price, right? This is the original price. How would we work with this? This is the original price. Let's see. Let's look at our way to check over this question now. I want you all to think through this with me now. They say Miss Rika spends, let's say we're gonna reword the question. So if the original price is $143.75 and they charge her a tax of 15%, what would be her final price? So we want to find the final price. You need to find 15% of this number, add it to this number, and if you get back $165.31, your mathematics was correct. So if you find what is 15% of the original price and you add it to the original price, you should be getting back 165. So let's actually just try it. Let's make another space here. I'll erase this after. So let's just try that. We know the original price is $143.75. And the tax is 15%. So what is 15%, which is 15 over 100, multiplied by $143.75? What is this working out to be? Now, this, what I put in black, you would not necessarily, you don't need to do this in the exam. This is just me showing you that we could check over this answer. This value, what does this work out to be? 15 over
0.56.
$21 and what?
56 cents.
56 cents. Right? If we this is the tax. This is the actual tax she paid. If we add this tax back to the original price, what would we get? So that would be $143.75. Add the tax of $21.56. What is that giving us?
165 and 51 cents.
So that means the final price she would have paid was what? 165.31. Isn't that the actual final price she spent? Look at the question. She spends $165.31 after the tax. So if we know the original value, we tax it, we add it back to the original, we got the same answer. We got back the same thing. So we guaranteed to know that our answer is correct. Okay, so these types of, now guys, so,
And you can just take away the 165 and 143 and get the 2156.
the 165, wait, that was something I just erased? The 165 and the fourth. Can you repeat that, please?
So when you minus the 165 and the 143, you get the 2156.
Yeah, right. But the thing is, yeah, you could have done that, but we when you minus the 143 from the 165, you got the $21.56. But the reason why I did it like this is I assumed that we are starting from the original price now. So let's say we go in our shop and the original price is this number in green here. They tell you 15%, you have to pay an extra 15% tax. How much would you actually spend on the item? So if it's originally $143.75, we need to work out how much in tax we would pay, the 15% tax, which works out to be $21.56. And if you add that to the actual original price, you will end up paying more. So that's the thing with taxes, because a tax a tax causes you to pay more. Always remember that. If the original price is $143.75 and you have to pay a tax, you end up digging deeper into your pockets and you end up paying $165.31. Always remember, taxes cause you to pay more. Discounts, what does a discount do then? Would you pay more or less?
Less.
So taxes cause you to pay more and discounts always lead you to pay less. All right, so this question Why I chose this particular question to do with you is this is not a straightforward question. And you see this other question part we're going to move on here to now. This one is a little more challenging. And I will be honest with you, this is going to, you need to take a drink of water. Let's look at this one. This one going to be a little more challenging. So let us analyze this question now. The ratio of the number of bananas to the number of oranges is 2 to 3. So what they're telling us here in this question is this lady gone and buy some bananas and oranges. All right, that's what she did. She bought some bananas and oranges. For every 2 bananas she bought, how much oranges did she buy?
3.
3. Yeah, that is how that ratio is. If she bought 2 bananas, that means she bought 3 oranges. So that is what that 2 to 3 ratio is. But they give you a next additional thing here. Furthermore, there are 24 more oranges than bananas. Calculate the number of bananas that she bought. Now, this question has nothing to do with any previous part of the question. This is a self-contained thing here. You do not need any prior knowledge from what we did before to answer this question. Everything that you need is right in here. Everything you need is right in the question. Okay? So everything you need right in this. Let us look at how we would go about handling a question like this. So this is a difficult question for the sake that it requires you to know ratios. And the intuition here is that you are going to end up using a little bit of algebra. You may not believe it, but it will have a little bit of algebra involved here. At least in the method I accustomed with for this question. So let's get started. Now I want you to look at this. I'm going to write some statements before I start this question. If there are 24 more oranges than bananas, can you tell me if we were to write like an expression for the number of bananas, what would you think? Very
X.
good. Yeah, yes. Because that is it. That's the first thing I'm going to write here. Okay, I'm going to write it here. Let number, N-O, number of bananas be X. And if there are 24 more oranges than bananas, what would be number of oranges?
X plus 24.
That is true, because if there's X bananas and 24 more oranges, there will be 24 plus X, right? So that is good. So let number of oranges, O-R-A-N-G-E-S, be, what did you get? X plus 24. Okay, so that is the first thing. If you all don't understand where we got that from, that is just something we are using to help us with the question. They told us that there are they told us that there are 24 more oranges than bananas. So if there were X bananas, there must be X plus 24 oranges. So far, we shouldn't be too confused. All right, that's the first thing we had to do there. Now that we get that done, let me make sure my audio and thing working here. Just a little bit of a difficult here. Now that we understand that, let's see how we could analyze this question further. Now, I'm gonna put oranges here and bananas here. O for oranges, B for bananas. And I'm going to put the ratio. In this ratio, 2 to 3 ratio there, which number represents oranges? Let me see if you all can pick up on these.
3.
Yeah, the 3 is the oranges, because look at the way they worded it. Okay, the ratio of the number of bananas to oranges. So oranges will be the second number. So I'm putting a 3 here. I will kind of show you why I'm putting oranges in front. You'll see why you're not in just now. Bananas. What number represents bananas?
2.
2. So I just, instead of ratioing bananas to oranges, I put oranges to bananas. But in reality, it's still the same thing. Okay? and it's still the same thing. The reason why I did that is because they want us to really calculate the number of bananas. And anytime I work in a question like these ratio type questions, you see the thing they want us to find, I always like to keep it on my right side. And you will see that when we put on the work in for this question. The thing that I want to find is always kept on my right side. That's just the way I like to work it. But it have other ways you could do this question. I've seen multiple methods to do it, but everyone did a little bit of algebra. You can't really escape the algebra in it. But this is just my way. So now that we're okay, I think everybody's still on the same page. What we need to do now is, you know how when we did this ratio here, I found for 1, it kind of helps us. I want to just find for 1 again. What would 1 be? If we're doing a ratio, wouldn't 1, for every 1 orange you buy, in a way, you would have bought what? How many bananas? If we're doing a 1, if we put a 1 there, wouldn't it be 2/3? Because look at it, the number of oranges is always bigger than the number of bananas. So if we have 1 orange, right? Orange 1, this number has to still be bigger than the number of bananas. That is how we do these ratios. This is how we do a general ratio. Now, if anyone in this class here is students I had taught in this school, you would understand the method of, well, we will drill ratios. We will do ratios earlier. Ratios are very important. If you know your ratios is a little bit difficult, that should be something that you need to focus on before your exam. Use YouTube. Let us be a wake-up call that ratios are something that is important in mathematics. Now, let's make it easier. Let's ignore everything else in the question. Let's just play with these numbers a little bit so that you get the idea of what I'm doing. If I had bought 6 oranges, I want you to think about the question. Is that 3-to-2 ratio? Eh? If I had bought 6 oranges, how many bananas would I have bought? So let's look at the ratio. Right, so let's look and see how we could work this. So the reason why I found 1 here is because if I had bought 6 oranges, to find the number of bananas, I need to take for 1 and multiply it by 6. So that would have been 2/3 times 6. 1 3 is 3, 2 3s are 6, 2 2s are 4. 4. Let's try our next one. Let's look at that again actually. Logic tells us that if we bought 6 oranges, that means we would have bought 4 bananas, because that is how a 3-to-2 ratio works. This is how this ratio works. If we multiply this number by 2, 3 2s are 6, 2 2s are 4. That's how this ratio works.
So I'm not really sure how you get the 2/3.
Okay, no problem. Let me show you. So when we're doing a ratio like this, you see when we did this one with the percentage, you see how we had 100, we had 100. Let's look at the numbers. Let's ignore the question. Let's just look at the numbers. We had 115% is basically being ratio to 165.31. 1%, you always divide this number on the right-hand side by the number on the left-hand side. So notice the 165 become the numerator, the 115 on the denominator. Right over left. That's the same thing what I basically did here. This is the number on the right, this is the number on the left. So I divide the number on the right by the number on the left. That's how we basically go about doing a ratio. This is a more complex ratio, but there are simpler examples, like when we now introduce in a topic like ratio. Let's say we have, let me give you another example of how to internalize what we do in there. Right, so let's say we have, that's not, I heard a noise there. Okay, right, let's take a break and let's look at how to handle some stuff in ratios, because I notice ratios is probably the weak point right now. So let's say we have we know that 10 books costs an easy number $50. Okay? I want you to visualize 10 books cost $50. How would you calculate how much one book costs? One
50
book
divided by 10.
50 divided by 10.
50 over 10. Isn't that the exact same principle we applied to this? Now notice, look at this, sir. This is the number on the left. This is the number on the right. And 50 over 10 is just the number on the left over the number on the right. So that's the same principle we applied here. Number on the left over the number on the right. Same principle we are applying here. Number on the left over the number on the right. It might be harder to see it with this question, but if you think about a ratio in a context of something you could visualize, like a book costing money, it makes sense now. Hopefully this makes sense why we would divide this number by 10. That is why we divided it for. Because this is a ratio still. All these things are ratios. This is just something that you could easily visualize the book. So what is the cost of one book then? What is 50 over 10?
5.
Five.
Right. So that is the same principle. Eh? When in doubt about something in mathematics, go back to something that you could visualize in your mind and then apply it to the question. That is why we divide. So it's the same thing like this ratio. It's a 3 to 2 ratio. To get 1, you divide the 2 by the 3. But you will see soon why I did that. Now, I will actually show you why I did that by this. So now that we know the cost of one book, guys, let's look at this. How much would 17 books cost? Can you all figure out how to figure out? I just make up this number. 10 books cost $50. One book would cost $5, right? This is $5. How would you figure out? How would you do it? 17 books. How would you find for 17 books?
Multiply 17 by 5.
Very good, right? So you multiply 17 by 5. Oops, you multiply 17 by 5. So 17 books would cost, would cost 17 by 5. Right? And that was what? 85? Well, regardless, you'll get the you'll got the point. So now that you saw this here, I need to remove it, but remember, we multiply the 17 by the 5. I want to show you how that same thing is going to help us in this question. That same logic, the way you think about it, is going to help us in this question now. So we know that for every one orange she bought, she technically bought 2/3 banana. That is what a 3 to 2 ratio is. Don't we know exactly how much orange she bought? We don't have a number, but we have an expression. That is where the algebra comes in. So you saw in that case how we wanted to find 17 books, and you multiply it by the $5. We know the actual number. Remember, this is the orange column here, and the other side is bananas. So we know the number of oranges she actually bought is x plus 24. X plus 24. This is a hard question, and this is why I'm doing it with you all for. Because it requires you to really think. So we don't have a pretty number, we have an expression. So if we know the number of oranges she bought is x at 24, what can we get an expression then in terms of x like this for the number of bananas with regard to the 24 using the same ratio principle we did before? So because we found for 1 to find for the number of bananas, all you need to do, remember how we took, this was like the 17, this was like the 5. Let me use different colors. Remember when we were doing it, this was the 17, this was the 5. We multiply the 17 by the 5. Same thing we're going to do here right now. We are going to, in order to find the number of bananas, you need to multiply the 2/3, let me use the blue, by the x plus 25. I'll go back to that again with you just now. 2/3 multiplied by the x plus 24. Let me go back for those who are confused about how we reach to this point. Let's go back to the analogy with the books. Let's start over that analogy clean. I want to compare step by step. If we get through this question today, guys, these types of ratio questions with algebra in it should not stress you out. We have to continue the questions soon, but let's take it step by step. Let's go back to something.
Yeah, continue, right?
Mm-hmm.
If you had put bananas first, would it have been 3/2?
I believe so. I would have to write it over to check, but it could be possible, right? I think it should be possible to be 3/2 if you had put bananas first.
Okay.
So, right, guys, let's go back to the analogy. So the analogy was that 10 books cost $50. One book costs 50/10 equals $5. So 17 books cost 17 multiplied by $5. That is the principle. What you all could visualize. You all could visualize this put it into books here. You all could visualize that. Let's compare it to what we did here. For every 3 oranges she bought 2 bananas. So if she had bought 1 orange, that means she would have to buy 2/3 of a banana. You divide the 50 by the 10. Let me increase the size of this mouse. Right? Change the color a little bit. Right. So the same way we divide the 50 by the 10 here. Same way we divide the 2 by the 3 here. So moving on. So let's move. So how do we find for 17 books? Because we know for 1, to find for 17, you multiply by the cost of 1. So we know here the number of oranges she actually bought was x plus 24. That is what we know. That's the number of oranges she bought, x plus 24. So to find the number of bananas she bought, we need to multiply the x plus 24 by the 2/3. The same way we had multiplied the 17 by the 5. Now, this here is almost the end of the intuition we need for the question. Watch this. We need to, in order to find the number of bananas, we need to generate an equation. And we are almost there to the equation. But didn't we also make this note on top here that the number of bananas is x? Did we just also noted that? So this must also be equal to x. And that is the full equation we need to solve to get this answer. Because we did the ratio. This is important. We had to do the ratio first. This was what we did. We did the ratio. And we need to tie it back to the fact that the number of bananas was x. So we had made that earlier, if you all remember. Let the number of bananas be x. Because we could set this equal to x, we have a full equation that, and if we solve for x, we solve for the number of bananas, and that is what they want us to calculate for the number of bananas. So all we have to do to end this question is solve for x in this rather complicated looking equation. How would we go about doing this? Let me show you how I would handle solving an equation that looks like this. Let's just look at the equation for now. Now we have no more ratios to worry about. In a question like this, I want to simply make my life as easy as possible in solving a question like this. Let's multiply the numerators first on this side. Let's look at this side. We have 2, and I'm putting a bracket to indicate I'm multiplying x plus 24. And my denominator for this, 3 times 1, given me 3. And this is equal to x over 1. This here is important. What we're doing is we are solving for x. This is linear equations, guys. Remember, you would have done this in your school, I don't know. solving a linear equation. This is a typical linear equation, but it's a little more challenging because we have a fraction involved. Once you have fractions, I'm hoping that you guys would have learned that in order to solve this, we need to cross multiply. Have you all ever heard of cross multiplication?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Now, that is why this is important for us here. We have to cross multiply. What cross multiplying is, you multiply the numerator by the denominator here, and you do the same thing on the other end. You multiply this numerator now by this denominator. That is what cross multiplication is. So let's do it. X times 3 would have given us 3x equals, what is the numerator here? This 2 open bracket x plus 24 multiplied by 1. When that's just anything by 1 is itself. So we would have 2 open bracket x plus 24. This should look more and more familiar to you because you would have done simpler ones looking like this in lower form. We need to get rid of this bracket. This bracket is obstructing us. So how do you get rid of brackets in algebra? How to get rid of those brackets?
Distributive law.
That is the answer. The last person, the distributive law. You all know what is the distributive law? That is when you take what's outside and multiply
And multiply by any brackets.
everything in the bracket. Very good. You have to take what's outside. Now, I wish if I was able to teach this topic to you in total. Now, I know that you all may have different aptitudes as it pertains to the topic. But at least if the ratios is a bit difficult and you need to sharpen the ratio, let's look at how to do the algebra portion here. Right? So yes, we multiply what's inside by what's outside by what's inside. So let's do it. So we have the 3x. Let me use the same green. You have the 3x here. That's equal to 2 times x is 2x. What is 2 times positive 24? That is positive 48.
48.
Very good. Now, remember, the goal is to solve for x because x is the number of bananas. At this point, we could use either an easy method or the hard method. Well, not the hard method, the actual accurate method. But the method I choose to tell students is if you're moving something across the equal sign, because this is a review course, what you do to the sign in front of the thing? You're supposed to change the sign. So we want to group terms. So on this side, I'm going to draw a line here to show you something. I want to put all the x's, all the stuff with the x's on one side of this equal sign, and all the numbers, I want to keep it on one side of the equal sign. So on this left side, and this is your right side, on the left side, I have 3x. If I move the 2x across, won't it become negative 2x? And, and 48 is already here, so it remains as 48. What is 3x take away 2x?
X.
3 apples, yeah, x. So x would be equal to 48. And that is the answer for this question. Because we had let the number of bananas be x. Once we found x as 48, calculate the number of bananas. The number of bananas she bought was 48. Let's just take a minute to review what we did here, because this is quite a lot of work in, right, to reach to this point for 2 marks, in my opinion, right? So let's look at what we did here. So what we're doing, because they told us the ratio of the number of bananas to the number of oranges is a 2-to-3 ratio, and they told you that there are 24 more oranges than bananas, I let the number of bananas be x, and the number of oranges be x add 24, because there are 24 more oranges than bananas. Because I have a ratio, I put oranges first, and I decided they told us it's every 3 oranges she bought 2 bananas. So that would mean if she had bought x plus 24 oranges, the number of bananas she would have bought would be 2 over 3 multiplied by x plus 24. That is this. This is in this expression in blue represents the number of bananas she bought. And we had let that be equal to x. So when I make this be equal to x now, I have an equation that I can solve for x. And all I did is I went through the steps of algebra to solve for x. And that is how I got the number of bananas she bought.
Excuse me, sir.
Mhm.
It have an easier way method to solve this. You could just multiply the number that they give you, which was the 24, by the number of ratios. So 24 by 2, you'll get the 48, and 24 by 3, you'll get the 72. So the 72 will be for how much oranges, and the 48 will be for how much bananas. So 2 minutes, 2 marks, easier way
Okay,
to.
no problem. But remember, that is true. That is true. But we have to also look at some algebra type questions here as well. So this kind of knocked off us a little bit of linear equations too. All right, so that is true, right? So you use the ratio like that. There are 24 more oranges than bananas. So you can also consider, there's a different method too, where I know, where you could consider the number of oranges as 2x and the number of bananas as 3x as well. And you could have worked as well with this method. Eh? So there are many different ways, but that is indeed correct. Now, the reason why I stress ratios and why I did this with ratios is because ratios are the foundation of basic mathematics. Now, this question here is let's quickly just move to this other question. Now, this other question we see in here, because of the interest of time, I'm going to pick some of these that I want us to look at. I wouldn't do a BODMAS question like this, but there is something here that I want us to look at, and that's this particular question. Let's just shift to not a consumer, it is a consumer arithmetic, but this is a compound interest question. Students tend to understand how to do simple interest, but they tend to forget how to do compound interest. So let's quickly look at a compound interest question to change it up a little bit. Right, so compound interest. Now, in this compound interest question, because we're looking at, we finished an hour, I want to blast you some more things here. In this compound interest question, we have this person and they went to the bank and they invest some money. And the bank pays compound interest at a rate of 2.5% per annum. Now, when you invest money in a bank, do you expect to come out with more or less money at the end of the day? What do you think would happen? More. You would want to have more money. Okay, that is really what you want. If you go in the bank with you wouldn't want to come out with less. Now they give you a complicated looking equation here. This is a complex equation. This is from January 2013. So let's look at how to do this question. So Mika invests a certain amount of money and in a bank that pays compound interest at a rate of 2.5%. What does annum means? Per annum means, what does that mean?
Per year.
Yeah.
Oh, yeah.
Very good. Now, at the end of 2 years, the value of our investment was $7,564. So they didn't tell us the amount of money she invested, which would be the principal, but we know the total amount she ended up with. Calculate the amount she invests. So what they want us to find is the principal, the original value, which is the amount she invested. So they give us this formula, and this is where we will begin this question by analyzing this formula. All we need to do is plug in information and solve for a variable. And that is what I will drill with you guys, is the algebra. So let's look at it. What's going on here? I'm going to write over the formula they gave us. They gave us the compound interest formula as A is equal to P, open bracket, 1 plus R over, I'll explain what R and stuff is soon, to the power of N. What is R? They told us R is the rate. Did they give us those things here? We have 25% per annum, and we have 2 years. So what is the rate based on this information? Which one is the rate?
2.5
per annum. So that is the rate. And very good. And at the end of the 2 years, so 2 years would be the N, which is the number of years the money was invested. So they gave us stuff, we just need to plug it in and solve. So what do you think is A? Look at this
The
here.
amount of money.
Right. So A is the amount of money. But no, it actually would not be the amount of money she invests.
2 years?
Because they want us to calculate the amount of money she invests. A, if you look at the diagram, A is the total amount after the amount of years. Didn't they give us that? At the end of 2 years, the amount of money is 7,564. So that is A. Okay, so A is this big number here, $7,564.50. This is A. Okay, we're done with A. What we're trying to find is P, because P is the principal or the original value, and they want us to calculate the amount she invests. They want us to find P. Open bracket, 1 plus, you all were correct with your rate. The rate was what? 2.5?
2.5.
Very good. Over 100. Close bracket. N was 2. So how much unknowns we have in this equation? I'm taking off the dollar sign. How much unknowns we have in this equation? How much variables
Just
we have
one.
here? Just one. So this should be very easy to solve. So how would we go about solving this? What I would do is I would try to solve this thing first. Or you could rearrange this whole equation. Or by catering for students who may not understand how to rearrange this equation. So the E, if you know you can't rearrange this, because you could, it's a way you could plug in everything, all these numbers into your calculator and find P. But for the students who may not understand that, all you need to do is let's solve this firstly on your calculators. 1 plus 2.5 over 100, all to the power of 2. If you work this out properly, you should get something looking like 1.05. If you were to work, you all got something like that. Who did this?
Yes, sir.
1.05. So now watch how easier the equation looks. 7564.50 is equal to 1.05 P. Isn't that looking a lot lighter already? So how do we find for P? We could divide both sides of the equation by the coefficient here. That is the, or you could just, that is what we see. If you were to get, remember we want to get P, but we have to get rid of the 1.05. So we will divide both sides by 1.05. 1.05. This would cancel. We get P, and we just need to work this out, and it would be a number that needs to be approximated, because 1 point, yeah. Right, so let's see, what would that work out to be? 7,000.
204
Right.
and 3 cents.
Right, so I'm going to just approximate it. You know why? Because when I did it without, remember this value here was an approximated value. But let's just go with what you got. 7,204.
4 and 3 cents.
Right, and 3 cents. But let's be real, she maybe really went in there because we have approximated this thing here. She maybe really invested around $7,200. That was how much she probably she really invested. This is for those who need to take steps. So this is the answer, around $7,200. And does that make sense to you?
Excuse me, sir.
Mm-hmm.
I confused where the 1.05 come from.
Sorry?
Where the 1.05 come from? I'm not too sure.
You're not sure? That's okay. The 1.05 is this thing here. I'm going to circle it in blue. If you put this into your calculator, you are going to get 1.05. Okay? That's where that 1.05 came from. Because you notice that what we have here is being multiplied by p. So that is why I have 1.05 p. What's inside the circle works out to be 1.05. Approximately 1.05. Is that a little better? If you put that into your calculator correctly, you should get something like 1.05.
Excuse me, sir.
Mm-hmm.
Do you have to round it off to 7,200?
No, because most students will input this in the thing a circle in blue, they will input that into their calculator. So you can leave it at the 7,204. Yeah, you can leave that. Right, but I just wanted to show you all logically, most likely she went in there with 7,200. The reason why we got the $4 is because we had approximated this to 1.05. It would have been some other decimals in there. All right, so that is our compound interest question. Notice what I'm showing earlier is algebra. The algebra here is very important. You need to plug in certain things into this question, and you need to solve for one variable. This is pure algebra here now. So this wouldn't take us to, this wouldn't be bad. This is actually quite simple algebra here now. We're going to be looking at not technical algebra like what we just saw. This question, two type questions, they spoon feed the question to you, meaning that they give you a question and they ask you to solve it. Not like how we had to generate equations, and in this one here, you had to generate this thing and put in your number, put in your R, put in your N. Nah. Right? So they'll spoon feed you certain things. As you can see, when we go down to the next set, you will see how these questions are spoon fed to you. You just have to solve them. So let's just look at this one now. Two quantities, N and T, are related as follows. N is equal to the square root of T. Okay, so I'm going to write it for those who can't see it. N is equal to the square root of T. Find the value of N when T is equal to 49. This is a very, very easy math, guys. What is this? What is the square root? N is equal, yeah, N is equal to 7. You could put the square root of 49 into your calculator and you're going to get 7. Okay, so that one is easy. Right, so that's one mark. Now look at this. Make T the subject of the formula. So how will we do that? I'm going to write back the original equation. The original equation is N is equal to the square root of T. How do we make T the subject of that formula? Do you all have
Square with both sides, sir?
Very good. So for those who are familiar and have competency with this, in order to get rid of a square root, you must do one thing. You must square. That is the only way to get rid of a square root. And what you do to one side of an equation must be done to the other. So if we square in here to get rid of that square root sign, you must also square here as well. So N squared will be equal to T. Now, is that making sense? Let's see. Let's test it with the same answer here, 7 and the 49. And 7 squared is equal to 49?
Yeah.
Right? So we could test it. These things, what I'm showing you all here, these things here are methods too. Well, not really methods. These things are basic manipulation of formula and stuff, right? And these things are, it might pop up in your ear from trends. This came back in 2021. But I think if these things come, these things will be easy giveaway marks for students. I don't think this is anything too difficult. Hopefully, you all could agree. Right? So this is a more technical version. Let's look at this question. This question going to be a bit complex. This one actually is, because you all know what type of equation this is? Anyone knows what type of equation that is?
Simultaneous.
No, it's not a simultaneous.
Quadratic.
It's a quadratic equation. Okay, so we're going to have to analyze this question now. This question is going to take up a little time because this one is a quadratic. Let's look at how to handle this. This is not a hard question, but it requires you to really think about it. So let's start reading. Ali is X years. Jim is 5 years older than Ali, and Chris is twice as old as Ali. Write expressions in terms of X for Jim's age and Chris's age. So if Ali is X and Jim is 5 years older, what would be Jim's age?
X plus 5.
5.
Very good. Right, that one easy. X plus 5. So because Ali is X.
Why would it,
Sorry, yeah?
why would it be x times 5?
Because X
Or X
times
squared.
5, very good question. X times 5 would means that Jim is 5 times her age. Okay, not 5 years older.
Okay.
You understand? 5 times her
Yes,
age. So if she's like 2 years old, not 2, if she's like 12 years old and he is 5 times 12, he'll be 60 years old. All right? Rather than just being 17. So that is
Okay,
why it's not a
understand.
multiplication. Very good. Right. So Chris's age. They say Chris is twice as old as Ali. So what would Chris 1 be then? Using that same intuition.
2x.
2x.
Very good. 2x. Because they say Chris is twice as old and Ali is X. So twice as old will be 2x. Okay, so we're good with that. This is 2 easy marks. Moving on now to the 3-mark portion. Now, this is where you can get confused if you don't read your question properly. In 2 years' time, the product of Ali and Chris's age will be the same as the square of Jim's present age. How are we sure that this quadratic equation represents the information given above? What would you do if you see this question in a paper? Would you do it? Would you leave it out? Would you just say, nah, that's not for me?
Try it.
You had to
I will
try
get
it.
for them.
Anybody might just be contented with the 2 marks on top there and say, let me just move on.
Yes.
That's what-
Just move
Yeah.
on. Just move on.
I'll just
Right, so let's see. Now, this one, I'm not gonna lie, it's going to look a little scary because we have some algebra to do, but it's not hard. This one really easy once you get the hang of it.
Do we transpose?
Transpose. Now we don't have transpose, but we have to combine. We had a combine. So you will see. Let's take a look. Right. So after this one, I'll move on. This is actually the end of this question anyway. We're going on to look at some question 2s. Actually, no, we're doing that already. Anyway, so watch how to do this question. The hint is to read what they have in bold. Now, I'm not gonna lie. I gave this question to somebody today, and they didn't read this properly, and they did some correct working, and they got the whole question wrong. And they struggled to figure the answer out because they didn't read this. They took this for granted. So in 2 years' time, what would Ali's age actually be? If Ali's age is X years old right now, how much will Ali's age be in 2 years' time?
X plus
X
2.
plus
X
2.
plus 2.
Right. So I'm writing down that here as X plus 2. Putting it in a bracket because we have plenty of things to put. Now, the same 2 years' time, the product of Ali's and Chris' age will be, we'll just think about the product of Ali's and Chris's age. So in 2 years' time, what would Chris's age be? Look at Chris's age right now.
2x
4x.
plus 2.
Very good. You see, you're done figuring it out already. 2x plus 2. They say in 2 years' time, the product. What does product means to do? Add, take away, subtract, or divide. Well, add, take away, multiply, or divide.
Multiply.
Very good. So we're going to have to do some multiplication with this. Well, let's just continue reading. It will be the same. What does same means? What symbol do you think we could put here? I will tell you to save it equal sign.
Equal sign.
It will be the same as the square of Jim's present age. What is Jim's present age?
X plus 5.
So you're going to square x plus 5. So you can write it as x plus 5 squared. But do you know that x plus 5 squared is x plus 5 multiplied by x plus 5? Did you all know that this is x plus 5 squared as well?
Yeah.
Yes, sir.
Yeah.
right? Because and if we have 2 squared, and that's 2 times 2,
Yeah.
so x plus 5 squared must be x plus 5 times itself, right? So nothing here should be. This is, look at what you just did here. Isn't this our equation?
Yeah.
Isn't the only variable in this thing x? Let's simplify this thing down. Let's try to simplify this now. So we're going to do, you all ever heard of a double bracket expansion?
Yes,
You
sir.
might. Now,
Yes,
if you,
sir.
you might not know the word, but look at what it is. It's called distribution. Somebody in the audience has said distribution today. You are distributing. You take what's now in a double bracket expansion, we multiply everything inside this bracket first by the x and then by the 2. So let's look at how I would do this double bracket expansion quickly for the sake of time. X times 2x. You all could probably help me get the answers when I say it. What is x times 2x?
2x
Squared.
squared. 2x squared.
2x squared, right? And what is x times 2?
2x.
2x.
Very good, right? Plus 2x. Moving on now. What is 2 times 2x?
4x.
4x.
Very good. Let me know if 4x. And what is 2 times 2?
4.
Right. So that is good. So what we did is we expanded this thing. Notice we already have something kind of quadratic like, eh? That is important. We put our equal sign. We're going to do the exact same thing to here now. What is x times x?
X squared.
X squared.
Very good. What is x times 5?
5x.
5x.
Plus, whoops, let me use the colors, right? Plus x times 5 is 5x.
5x.
Right? Moving on. What is 5 times x?
5x.
Right. Plus 5x. What is 5 times 5?
25.
Very good. So isn't it so far not as bad as we thinking? Right? So we just expanded. Are we seeing like terms here?
Yeah.
Yes, sir.
So that is the key here. I want to group all my like terms together now. So what like terms are we seeing? We have some
2x
x
and
squared.
4x.
4x.
So let's try to write it over and group our like terms. So here we have 2x squared. And you see where we have the x squared there? If we move this onto this side, wouldn't it become minus 2x? Look at it, huh? We're moving this across. I want to group everything on one side of this equal sign. What I want to do, let me show you, is I want to transfer all of this information across to this side of the equal sign. And I will tell you why I'm doing it. Because if I look at the answer they get, we have 0 on the right side. That means that they transferred everything here to this side, so they left with nothing here. That is what that means. So if I am transferring my x squared, it will have to become minus x squared. So I'll have 2x minus x squared there. Because once I move something, I need to change the sign. The other way you could describe it is you need to take away x squared from here in order to remove it. But I don't want to get into the technical stuff. We're going in the easier route right now. If we want to move the 5x across, what would happen to that? Wouldn't we also have to change the sign? It will be minus
sir.
It will
5x.
be minus 5x.
Minus 5x.
Right. So let me just put down what I have over here first, right? So we have plus 2x plus 4x. You could start simplifying it if you want already, you know. But I want to move these things across. So it can become minus 5x minus 5x because we had 2 of them. All right. And then the positive 25. If we move it across, it's going to become minus 25. So it have nothing now left on the right side.
So you forget the 4.
At our 4? Oh, yes. Very good. I did forget the 4. Plus 4. This is the 4 here, right? It remains. I have to put plus 4. Thank you. Plus 4. Right? So I have nothing on the right side. Now I know it's looking like a mess, but we're going to simplify like terms. What is 2x take away? 2x squared take away x squared. This is 2x squared. What is 2x squared take away x squared?
X squared.
2x squared.
Correct.
Now 1. It's like you have 2 of something taken away 1 of something. Right? So it would just be x squared. Anybody don't understand how 2x squared take away x squared is x squared? Yeah, that's the answer, right? 2x squared take away an x squared is going to give us an x squared. Hopefully you'll understand that one. Look at the variable here. X, 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 x. Isn't all of these things have the same variable?
Yes,
What would
sir.
happen if you simplify all of this? You could add them. What is positive 2, add 4, take away 5, take away 5? What would that simplify to be on a calculator?
5x.
5x? It will be, let me try it on my calculator, because I'm doing it for the first time here. 2, add 4, take away 5, take away 5.
Negative 4.
Negative 4.
Negative 4.
So, but we have to keep the x. So it will be negative 4x. Negative 4x. And what is, let's simplify the numbers here now. Minus 25 plus 4. What is that on your
Minus
calculator?
Minus 21.
Negative
Minus
21.
21. And we put our equal 0. Isn't this what we started off with?
Yes, sir.
What they
Yes,
asked
sir.
us to find? Look at what they asked us to find up here. Let me use red. This is what they wanted us to find. X squared take away 4x take away 21 equals 0. That is what we simplified it to get.
Sir,
Mm-hmm.
could you elaborate on how we got the x plus 2 again? Whose age were we adding?
X plus 2. Which x plus 2 is that? No problem. Up here? Oh,
Yeah.
quite up here. No problem. In 2 years' time, they told us Ali's age and Chris's age, they want us to multiply these children's age in 2 years' time. Meaning that if her age is presently X, in 2 years, her age will be X, add 2 more years. Is that making sense? If her age is currently X, in 2 more years, it will be X, add 2. And the
Yes.
same way, if Chris's age is 2X, it will be 2X plus 2 again, because you're just adding 2 years to their current age. The next part is to calculate her present age. What do you think you had to do here? Once we found this quadratic, guys, what they're asking us to really do here is to solve this quadratic equation. That is what we do here in order to find her present age. Because isn't her present age X? X. That is how much years she is. What is the variable in this equation we just found? X.
X.
So if we solve this equation, we solve for what? Y? Z? No, we solve
X.
for X. So to get a present age, we have to solve this equation for X. So my question is, do you remember how to solve a quadratic equation? There are multiple methods you can use to solve a quadratic equation. There's the quadratic formula. There is the factorization. Right, and actually that's the one I will just use. Let's just use the factorization method here. So this is us recapping now. Now, for those who do not know how to factorize a quadratic equation, pay attention to this. This is actually, they could give you equations like this in the exam and ask you to factorize them. Huh? I've seen blatant questions where they give you a quadratic and say factorize that. This question make you work for your quadratic equation. But now let's factorize it. So we're going to write over the question, x squared minus 4x minus 21 equals 0. Now, what is you all ever heard of something called the general form of a quadratic equation?
Yes, sir.
What is it?
No, sir.
AX squared plus BX plus C.
Yes. Anybody here never heard of that before?
Yes, sir.
Well, you
Yes,
might.
sir.
Okay,
Yes,
no,
sir.
you might have heard the general form, but I'm pretty sure you heard ax squared plus bx plus c. I'm pretty sure most of you heard that. This is how we're going to factorize this. I want you to tell me. Now notice, the x squareds line up, the x's line up. So if I ask you what a is, you should not be saying x squared in that. If I ask you what b is, you shouldn't be saying including x, because x is not b. The x's are something separate. So what I want you all to tell me, what from just how these things are lined up, what is a, what is b, and what is c?
A is 1.
Sure, is 1.
A is
Right.
1, B is 4, negative
A
is
Wait,
1.
A is 1. So those who don't know, if you have an x on its own, there's always an imaginary 1 in front of it.
Sir, why would it be 1 squared?
Sorry, why would it be what? I didn't hear the question.
1 squared.
1 squared? No, it would just be 1. A would just be 1 because the number in front of the x squared is going to be 1. In algebra, if you have a number, like if you have a letter like y, there's always certain things about that. There's always going to be a 1 in front of it and a power of 1. 1y to the power of 1 is just y. Those are just simple things I want you to remember about algebra. So there's going to be a 1 in front of that x squared. The b, what is b? This is important. What is b?
Negative 4.
Negative 4.
Not 4. B is negative 4. You cannot forget the sign in front of the 4. And a lot of students tend to forget the sign and they struggle with this question. With that in mind, what is C?
Negative.
Negative
1.
Very good. You did not forget the sign. Why did we find A, B, and C? Using the factorization method, what we do in solving a quadratic equation is we need to do something to this 4x here. Something has to be done to that. You all know what we kind of do there?
Yes, so you have to get
Something with the A and C.
Factor.
Yeah, something with the A and C. I like that, right? Something with that A and C there. This A and the C, something. So let me start you off. Something. Tell me if the song is familiar now, for those who are accustomed with this. Something plus something is going to be equal to something. Something plus something is equal to
C.
C. C? No. Something plus something is
B.
going to be equal to B. Right? Yes, it's B. And I will show you eventually why. And something multiplied by something is going to be equal to what?
AC.
AC. Very good. What does AC mean? Like air condition? No.
A
A by C.
A multiplied by C. Guys, just give me a second. 1 second. Right, sorry about that. I know it had a little noise intrusion there. Right, so let's put in some numbers. AC means A multiplied by C, guys. So what is B? From this information here, B is negative 4. Can you see that?
Yes, sir.
AC
Yes, sir.
is what? What is AC? A add C or A
Negative.
multiplied by C?
Multiply.
Multiply.
So what is 1 multiplied by negative 21?
21.
Negative 21. So you all see the issue here now, right? We need to figure out what two numbers will add to give B, but if you multiply them, you get negative 21.
Negative 7 and 3.
Let's see. Yeah, that's actually it. Right? So you are on top of this already. So let's use a color here. Let's just use the red. So let's see if it makes sense. Negative 7 and 3. Let's see if it satisfies this. What is negative? If negative 7 add 3 is indeed negative 4. Now, if your directed numbers, which is your positive and negative numbers, are a bit weak, guys, you have a calculator in this test. Use it. Okay? Negative 7 add 3 is negative 4. And negative 7 multiplied by 3 is equal to negative 21. So these are our important numbers. What we're going to do with those numbers now? Are we just going to leave a question right there?
The equation.
Right. So remember, we split B into these two things, and there was a reason why we did it. Let's look at how this works out for us now. So what we're going to do is write back our original equation. Right? I'm going to write it back. It was x, with was my point. The original equation is x squared minus 4x take away 21 equals 0. But the 4x is actually being split into 2. And that is what we are doing here. That is why we got these two values. So watch what happens. The x squared remains. We didn't touch that. But the minus 4x split into minus 7x plus 3x. Because n minus 7x plus 3x is going to give you back minus 4x. Then you put the minus 21 equals 0. Have you all ever heard of factorization by grouping?
Yes,
Yes,
sir.
sir.
Because that is why we did all of this work on the right. We needed 4 terms in order to do factorization by grouping. 1, 2, 3, 4. You have to have 4 terms before you can do factorization by grouping. So let's put brackets. When you're doing factorization by grouping, you must put brackets. And for those who understand what we're going to do next, please do not do this. Do not put your addition or whatever sign you may have in the middle here, like in between those brackets. That is wrong. If you are in the habit of doing that, cut it out, right? That sign, this positive, belongs to this 3x. That is the property of that 3x. It wants to be included in the bracket as well. Now that we've done this grouping, what do we do next in this factorization method of solving a quadratic?
Put it in the group.
Well, we do something now. Each group in here, we do
And the common
basic
factors.
factorization. Very good. We find the common factor. What is the common factor inside this first grouping? We have 2 terms here. What is common to both of these terms? We have x squared and I had 3. Now, we only looking at this first grouping here. The only thing shared is
7.
x. Now, we're looking at what present in both. So the x here and another x here. So these 2 terms share x. So x is the only thing that is common. I hope you're all seeing that. X is the only thing that is common. Now, you might be tempted to put x squared, but if I had more time, I would love to go down that whole rabbit hole and show you all why it's not x squared. But it is certainly just x. Now that we see x there, what do you think we're going to put inside our brackets? This is what we call the HCF. So I'm going to put it and I will show you why it is. It is x minus 7. And look why. For those who are familiar with this thing called factorization by grouping, x multiplied by x will give us back the x squared. And x multiplied by the negative 7 will give us back the negative 7x. Another way you could have think about this, in order to figure out what goes inside that bracket there, what you could have done also is, what I normally show students is you take these terms and divide them by your factor, your common factor. So if you don't understand what we just did, x squared is x times x. If you divide that by the common factor x, watch what happens. You get a x that goes in the bracket. Also, this is just for students who don't understand these kind of things. I'm just doing this additional thing here. This negative 7x here, negative 7x. If you divide it by the common factor x, what are we left with? Minus 7.
Okay.
So that is just something to show the rest of you guys how we got that inside the brackets. Now, what is the fun thing about factorization by grouping? Once you figure out what's in one bracket, isn't that
The same in the next bracket.
very good? That's the same in the next bracket right here. That is always going to happen. Whatever you find in this first bracket always pops up in the second bracket. Always. If you're getting something else here, guys, you're wrong. So we just need to find what number goes here. Now, what number you think goes there?
3.
3.
3.
Let me show you why 3 is correct. Positive 3 for that matter. But let me show you why 3 is correct. For those who don't know, remember the same way we multiply it across and we can get back that? We're going to do the same thing. 3 times x is going to give us 3x. 3 times negative 7 is going to give us negative 21. Right? So that's just to check it over. Are we finished here? No. We need to do what is called factor. We have to group some
find
stuff.
x.
Right? So let's group it first. Let's put down the factors. What are the factors going to be? Wouldn't the factors be
Minus 7 and x plus 3.
right? So x plus 3, what's outside your brackets, which is x plus 3, and what's inside the brackets, which was x minus 7. These are your factors. But are we finished? No, the goal is to solve for x. We are not finished. Now remember that this equation was equal to 0. That means that these factors are also equal to 0. The way we finish this question, is by setting each factor equal to 0 and solving for x. Is that sounding familiar to some of you? Look at it. You put x plus 3 equal to 0, and you say x is equal to negative 3. And the other one, x minus 7 equals 0. So x will be equal to what?
7.
7. But we get 2 different values of x. So did we do something wrong? Or is this expected for a quadratic equation? It is expected. But how could Ali have 2h? This is where you need to think logically now. Is it possible for she to be negative 3 years old?
No.
So, no, it's not possible. So her actual age is going to be which one of these answers?
7.
So her age equals 7 years. Okay, so this is a quadratic equation question where you generated a quadratic equation and then we factorized that quadratic equation. Look at how technical this question came. This was which paper was this? June 2021. They come real tough June 2021. Right? So there are other ways you could solve for x using the quadratic formula, completing the square, etc. But this is tend to be the easier method students tend to appreciate. If you have trouble with this question, you need to review quadratic equations. Okay? Quadratic equations. Take note of that. What we did here is quadratic equations. Now, I'm looking at the time, and I want us in the last 10 minutes to do some multiple choice questions. Okay, so I want us to do some multiple choice questions. But before we reach to that, I will continue from this next week, next day, right? Let us do some of these simple. These are some questions which came in January 2023. So these are the exams that would have just come. Some of you in school would have probably got mock tests and would have seen these things in your mock tests. Let's see how to handle some of these types of questions. These wouldn't take us long, right? And we'll try to see if we could do all this one. I wanted to do this one with you. So I'm looking at the time. I believe we should do it up to here, right? Next day I'll prioritize some multiple choice. I will do some question trees with the multiple choice. These are trig related questions. I will post this document for you so you could try these questions that I didn't do as well, right? So we could probably move it a little faster. So I have some questions here that I want you all to try. So let's see if you could do this question out in the 15 minutes. Let's see, because you would only take 15 minutes to do a question in the exam. I remember I tell you, time yourself, 15 minutes per question. There are 10 questions. Look at this question now. Before I tell you what type of question this is, what topic is this? Do you all know? What is this topic?
In the seas.
In the seas, not like in the water, eh? Not like that kind of sea. This topic is in the seas.
Sorry, is it equal to x to the 6?
Yes. Right, that is correct. So there are rules of indices. How much of you know those rules by heart by now? There are about 5 important rules, right? So if you do not know what I am talking about, take a note of that. Rules of indices. Please, that is the topic that will be coming. So let me show you an easy way to do this. This type, you multiply your powers. That is the easy way, actually. But there's another way you could think about it using the basic rules of indices. The basic rules of indices say that if you have x to the power of a and you multiply it by x to the power of b, because you have the same bases, you can do what to the powers?
Add.
Multiplied. Add.
Add the powers, right? So that will be x to the power a plus b. That's the basic, one of the most basic rule of indices you see in here. So I gotta make this into that. Isn't x plus 3 squared the same as x? Sorry, x cubed squared the same as x cubed multiplied by x cubed? Anything, yeah, it's by anything squared is multiplying something by itself. So we have the same basis. So what do we do to the powers?
Add it.
So the x to the power 3 and 3 is 6, not 9. Eh? You might be tempted. 3 add 3 is 6, not 9. So that's the answer, x to the power 6. Now we're going on to division. When we have the same bases, for the interest of time, when we divide and we have the same bases, what do we do to the power?
Subtract.
We take away your powers. So these are rules of indices. When you have the same base and you are dividing, you take away the power. Now be careful with the directed numbers. Look at what the answer is going to be. Why 8 to the power of 8 take away -5. Look at that. It's not 8 take away 5. This number is -5. So it's 8 take away -5. What is 8 take away -5?
13.
13.
How much of you would have said 8 take away 5 is 3? Be honest with yourself, huh? This is to make mistakes now. The power is 13 there. Right? Factorizing. Let's see. This is a general, that's why I'm happy we at least got a lot of algebra out of the way today. And right, so let's look at this one, x, y. Let's look at this factorize. You see this word? This word strikes fear into the hearts of students. I don't know why. Right? This word students hate to see it. They don't like to see that word factorize at all. Now, actually, I understand why they don't like it. The point is, when you're factorizing, you need to look at something in common. You look at what these two terms have in common with each other. You know, like something they share. So we have x, y minus y squared. What is common to both?
Y.
Y. So y goes outside the bracket because it is common to both terms. So what goes in the bracket? For the interest of time, it will be x minus y. Let me show you why. Y times x will give us back xy. And and y times negative y will give us negative y squared. Right? So these are easy giveaway marks in an exam. What about b?
Sure, that's the difference of two squares.
Very good. That's it. Difference of two squares. Because you cannot find, you might be looking at this in the exam, but wait now, x squared minus y squared, it have nothing in common. This can't. I know how much students write this.
Oh, seriously, that'd be one bracket have plus.
You know how much students wrote that? No, guys, do not do that. This is called a difference of two squares because x squared is being taken away from y squared. This is a difference. Difference means to take away two squared numbers. This is the difference of two squares. So how we write our answer is we square root each term. So if the square root of x squared is x, the square root of y squared is y. You put a plus, and then you write it back again with a minus sign. That is all. There's nothing else to this. x, the square root of x squared is x. The square root of y squared is y.
Sir,
You put
why
a plus.
why wouldn't you combine x and y and make it equal to xy squared? Is it because it's two different?
Yeah, that's something else. Okay. But I like the question though. Let's not rush it. Let's test our answers. Do you know that the opposite of factorization is expansion or distribution? Did you know that?
Yes,
So let's
sir.
Yes, sir.
distribute here and see if we get back the answer. Let's always test it, right? X, let's distribute it. What is x times x?
X squared.
Right. What is x times negative y? Pay attention to the sign.
Negative y squared.
Negative y squared.
Negative y squared.
No, because it's x.
Negative xy.
Right, negative xy, because we have an x being multiplied by a y, so it's negative xy. No problems. What about this one now? Positive y times positive x.
Plus y.
Plus yx.
Yx, but I'm gonna just put the xy for making it in alphabetical order, all right? I hope that's not scaring you all. And what is positive y times negative
Y squared.
Negative y
Negative
squared.
y squared.
It's
Are
negative
we
y
seeing
squared.
what? That's not an audio effect. That's sounding good, right? Anyway, what is the? Do we have any like terms here?
Yeah.
Yes, sir.
These are like terms. We have positive xy. Sorry, negative xy plus xy. What happens to that?
They cancel.
They cancel each other because you have it come like you have negative 1 plus 1, and that's 0, right? They cancel
Yeah.
each other out. So these two things goes to 0, right? These things goes to 0. So when this thing cancels out, what are we left with? X squared minus y. Oh, this was a square, eh? Yeah, y squared. Because remember, y times y is y squared. Nobody picked up on that. They're probably tired now. Isn't that what we started off with?
Yep.
So we are guaranteed our answer is correct. So you all learned now that the opposite of factorization is expansion, or sorry, distribution, right? So let's do this one now. Let's for the interest.
Cancel out the two xy's in the middle.
Yes, they cancel out in the middle there because one, if you look at it, this is negative xy, this is positive xy. If you add them together, you end up with 0 because one is the negative version, the other is positive. If you take a calculator and you type in any number, let's use number 7, and you put positive 7, take away, no, let's use negative first. Negative 7 plus 7, you're going to get 0. Similarly, negative xy plus xy is going to be 0. So they cancel out. Okay? X squared minus y squared. Now let's do this part quickly. Simplify this expression. How do we simplify this expression? Hence, simplify this expression. What does that word hence mean? It means they require you to use some of the information we gained earlier. That is what that word means. They are implying that we need to look a little bit above and don't forget it. Because what we do is look at this xy take away y squared. Didn't we factorize that here? Xy take away y squared. So we put the answer y open bracket x minus y. That's what we got. Y open bracket x minus y. That's what we got when we factorize it. We're just using the answers now, right? And the denominator was the difference of two squares. So we just did. What did we get? The stuff in yellow. X plus y, x minus y. So that would be on the bottom. X plus y and x minus y. Can we simplify this? No. Is that anything we could cancel out there?
Yeah, the xy.
We have a x minus y here. Let me use red. And we have a x minus y there. You all saw that? They can cancel out because they are the same. So what are we left with?
Oh, yes, sir.
Very good.
Over x plus y.
Right, and that's the answer. I will accept that. Right, that's the answer for that. Okay, that's just one mark. So we have 5 minutes. I don't know if that would be enough time to do this question. Let me just take a minute. Another minute. I would have. I do not think we will get time to do this question. Oh, but we will look at this one tomorrow. Okay, tomorrow I will look at this question. This is a fun question. I want you all to try this. For those who are coming back, try this question. It is very similar to this question we did here, where we link these two equations and stuff is very similar to that. This is a wonderful question that you should test your skills with. We'll correct this question tomorrow, and we'll be doing some trigonometry and stuff tomorrow, right? But we have a few minutes. Let's just do a few random multiple choice to end off the period, right? The class today, right? This is July 2021 paper, which was a technically difficult paper. Let's just take a few other 5 minutes and just do some of these multiple choice, right? So let's look at number 1. Right, let's look at some actually easier. I want to see some more technical. Let me pick out some what I want you to do. Right, let's see if there's anything here that I want. Okay, so we talked about distribution a lot. Do you understand what you're seeing in this particular question? Using the distributive property.
Yes.
You're seeing what to do in this? Let's look. Let me show you for those who can't understand this question. This is 49 times 7 and 49 times 3. That is very important.
Sorry, isn't it 49 times 17?
Right. So, but watch this. This is the distributive law. So wouldn't this be the exact same as doing this?
Yeah.
So if I distribute now, wouldn't I get 49 times 17? And then we got here plus 49 times 3? Yeah. Isn't that this? This is a distributive law. That is what they required you to realize here. But what is 17 add 3 now?
20.
So the answer is 49 times 20. Right? So that is 1. Let's look at this one here. It's right below for convenience sake. A test was marked out of 80. A boy scored 60% of the marks. How much marks did he score? What would you do here? We ended off with some nice questions.
Then
what would you do here? A test was marked out
60% of 80.
Right. 60% of 80. What does that work out to?
48.
Very good. Right?
Ben, why you look for me? You can't use the
really
bathroom
easy
at work.
questions here.
Why?
This question actually I wanted you all to see. Now, sets is a very difficult thing. That's an easy thing that students forget. Now, sets are only tested in the multiple choice, right? They don't really bring no long question on sets. Again, you will probably recognize that from past papers. Do you know, let's say they give you a set. For those who do in sets, who know this, how do you know the formula to figure out subsets? Do you know that there's a formula for this?
So n?
Okay, anytime you want to figure out the number of subsets, the formula is 2 to the power n, where n is the number of elements inside your set. How many elements are there inside the set?
3.
So our answer will be 2 to the power of
3.
This is something that I think you all may have forgotten, so I wanted to point this one out to you. This is sets that you would have done in lower form predominantly. In a subset type question, where they ask you to figure out subsets, you use the formula 2 to the power of n, where n is the number of elements inside your set. It's 8 o'clock. Last question to end it off. We'll do some more tomorrow.
Sir, it's not 8 o'clock yet. So it's 7 right now.
The set of positive integers is an example of what type of set? An infinite set, finite, empty, infinite, improper. What do you think? Positive integers. What is an integer? Do you remember what are your integers? Integers, positive and negative numbers, basically, right? So what type of set would you classify this as?
Infinite?
Infinite.
It is an infinite because you could have positive infinite. You could count from now to forever and you are never going to reach infinity. So this is actually an infinite set, right? So that will be infinity C. So we'll do some more of these. This is one I want us to do as well tomorrow. our last session, we're going to be doing a lot of multiple choice, heavily multiple choice. So I want to finish some questions from the paper too. By the third session, so the last session, we're going to cover multiple choice quite a lot. So I just wanted us to sample a few here. All right, so guys, I wish if we had some more time. I'm looking forward to doing this question with you, because this question.
Sir, didn't you say
So by then
you
it's
was
7
gonna
o'clock.
finish 8 o'clock?
Yeah, wait. Actually, wait.
It's 7 o'clock now.
We started
Oh, the
6.
time different.
Yes, the time's a bit different here. It's 8 o'clock here now, right? The time is. Oh yeah, some of you are not in Trinidad. Yeah, we started 6.
Yes, sir.
So by our time here, we started 6. So by now it would be 2 hours would have passed. Okay, but
Excuse me, sir.
yeah, time flies.
This
Sorry, I'm not hearing
record-
you.
Will
Sir,
you be sharing this recording?
Yes, it's recording. It's recording. Okay.
Will
So
you be posting it?
yes, it will be posted. I think they say by 8 o'clock tomorrow morning. Now,
In the Google Classroom?
I think it will be in the Google Classroom, yes. And
Okay.
also, I've posted these notes which I'm writing on. You all can choose to answer these questions before tomorrow's class as well, right? I would probably not be. I have some more questions to move on to tomorrow, so I might be able to do all of these. But it's good practice. Okay, it's still practice, but definitely tomorrow I'm doing this question with you. This is a beautiful question that we need to do. Okay, and then we're going to do some easy tricks.
So will you be doing everything on the syllabus?
What I can do is you see how the question paper is structured. There are 10 questions. So what I can do in the limited time we have is, because it's a past paper based review, I'm going to tackle various question 1s, various question 2s, various question 3s. And that's how and I selected the questions to get a diversity from the syllabus. So notice this test indices. This one here tests quadratics, which tends to come in your algebra portion. And I chose this particular method here in order to test solving linear equations for this particular question. It might have been a longer method, but I use it to kind of show this portion here how to solve a linear equation. So there are this is the limits we are working on is time. Yeah, the time is what we have against
A
us.
question.
Will we be doing any question like 8, 9, and 10?
Yes, that is definitely on the agenda. We're doing all. So
Hi,
we did some.
Second You'll be posting these past papers inside of the Google Classroom.
Yes, these questions we do in here, what I compiled on this document, I'm going to be posting the same document with all these writing on it for you right after the session ends right now.
Okay,
right?
not a problem.
So all these questions, and you all can do them, so you all can get practice with them too, you know. So
Excuse,
remember,
sir. Was only maths are they doing as of right now, or they adding on other subjects as they go along?
Right now, is it because this, you mean for the crash course or in general for the school?
Crash course.
Oh no, it's
it's
just maths right now for the crash course. But I think they would probably consider implementing others as the years go by. But for now, it's just maths. All right, I think it's one of the first times I think I'm doing this with the school. Yeah. All right, so I don't think it have any for English.
I have a question not pertaining to this per se, but do you know where I could get like any more free crash courses like these?
Unsure. But if it's past papers, you all know that there are a wealth of resources on the internet. For example, all of these questions, I'm pretty sure if you Google search, you're going to find solutions. What you might find is how to do these. You might just get the answers with some working, but you won't get somebody to guide you through like what you'll get in this course. So I don't know if you have any more of these free crash courses, but I can tell you with this generation, you all are blessed with the internet, and everything is on YouTube.
You could also plug it in on Mathsolve and you go get the
Yes,
step by
there's
step.
Wolfram Alpha, there's Wolfram Alpha, there's other software like that online. Right, so you could use those things. But today I really wanted to tackle a little bit of the algebra because I want you all to see how the algebra comes. Question 1 is not, that's why I chose a hard method here, that I wanted to tackle how to solve an equation looking complicated like this. And I use different colors so you can guide yourself. This is a complex equation, and if you could solve for x here, that puts you in a good position. Similarly, this here is where you have to substitute numbers into an equation. In doing so, if you could solve for your answer, that puts you in a good position. These are basic ones, these are easy. But this question, you had to create your own quadratic and then factorize it. This is a good question. These other questions is basic indices, right? But it requires you to use some skill. This question, however, is a real one, which you're going to be doing next day. Definitely, I'm doing this with you. I want you to try it. By the way, take away m from n, if anybody going to do it. Don't take away n from m. Because that's a hint. When you're doing the question, you'll understand. Okay? I want you all to try this one and come back tomorrow, because this question this came this year. This is the January 2020. This is a January 2023 question. If you never see this question before, it's because it came this year. Okay, so try this one. Next year we will do this one, okay?
So you can keep it longer.
I would love to, right? But have other engagements, right? A few other engagements. But the 2 hours, next day we'll move a little faster. You see, we have the introductions out of the way. Let's just move fast. We're going into this question as soon as 6 o'clock reach. And the rest of these questions on this paper are easy. If you look at it, these things are not hard. These are geometrical transformations. These things are going to take us too much time, okay? The rest of the questions on this paper is very simple stuff. So even if we don't do it, I will put the answers on these things and upload it for you. What we can't get to do, I'll put the answers and upload the answers in a later document. But I want us to...
Generally, as a teacher, right, which one of the questions do students face the most problems with?
Algebra. I'm sorry, that's the truth. Algebra is the weak point, and trigonometry. But I have started to see vectors and matrices giving students a lot of problems as well, right? Even though that is considered a hard topic for students, tend to, once they learn it, they tend to understand it. But recently I realized that students forgetting some basic stuff with vectors and matrices. And you have to do a vectors question. You don't know it at a time when that was an option. Now it's a compulsory thing. You have to do a vectors question. So I cannot wait to do a vectors question with you in the coming days when we reach that part, right? So I'm looking forward to doing a vectors question with you coming up. But the problem is basically the students' algebra. They forget directed numbers. They forget basic things like expansions, like the simple expansion we see in here, x plus 5 multiplied by x plus 5. If the directed numbers are given trouble, they can't do directed numbers, run into problems right here. So make sure you could do your directed numbers. What is directed numbers? Negative and positive numbers. Add positive and negative, take them away, multiply them, divide them. Make sure you know those things. Your orders of operations, BODMAS. Your foundation is what you stand on. If your foundation is not strong, all of this collapses. You need that foundation, okay? And your algebra is dependent on how good you work with positive and negative numbers. So if you take a few minutes and refresh basic positive and negative numbers question, right? So if you've seen something like -2 plus -3, what would that be? If this is scaring you, you need to refresh your negative numbers. This is -2, take away 3, which is equal to -5. If questions like these are bothersome to you, you need to spend time on directed numbers. That is a weak point in students. They don't understand your directed numbers. Even at this level, these are Form 1 stuff. Students tend to falter in that. Right? Do you have any more questions? Most of you are still here. All right. If you have no more questions, guys, that's it. I will continue tomorrow. But if you have any questions, you can ask. Right?
So would you be going through some circular theorem questions?
Yes,
Because I find that
definitely.
very.
Yes, we're going to be doing a circle
I just have problems
theorem.
with that.
Right? I'm definitely
there are a
doing
lot of
circle theorems with you. Right? And I have a video I could post for you all to when the time reach. That will guide you with circle theorem. So I'm doing one of every type of question. So today, honestly, we didn't cover as much as I wanted to cover, but I will tailor the content for the next few days, and we should be able to get the content done. All right, but I still think it's a great job we did question 1 and 2 today. Out of the 10 questions, that's not bad. The third question here on trigs and shapes, it's not that much. We can finish this easy. But yeah,
So some of us wanted to make a WhatsApp group chat.
you all could feel free to do that. Yeah.
Yes, sir.
Yeah, you all feel free to
Hey, you
share
want
the
to join?
contacts and stuff, socialize, because you all be feeling
Yeah, man, I don't know.
Robot voice.
Hmm?
Someone have on a robot voice changer or something.
Yeah, somebody does that. It sounds cool, but I really don't know how they did it. All right, so
Exactly, teacher, and everyone.
I'm going to just stop the recording. I realize we don't need all this being recorded. All right.
So if you don't mind, I could